Well, my privilege to welcome everybody to this webinar. In case you don't know me, my name is Justin Furness, Senior Consultant at Council for Aluminium in Building, and very pleased to have Azar Nalakath and Abiodun Ayodeji online to present to us on this exciting topic of AI. If you could indulge me by way of introduction, I noticed yesterday there was a Microsoft survey, some 1,500 UK senior leaders across private, public sector, as well as some 1,400 employees. More than half of executives felt their organization had no official AI plan, no strategy. And roughly the same proportions thought there was a growing gap in productivity between employees that are using AI and those that aren't. And I thought it was a good quote from the boss of Microsoft, who are indeed very much involved in AI as the backer of ChatGPT through OpenAI. And he said, some organizations appear to be stuck in neutral, caught in the experimentation phase rather than in the deployment of AI. So I thought that was very interesting. Um, so welcome to Azar and Abiodun, and we're going to explore how AI and virtual reality technologies will revolutionize processes across construction and across indeed our own supply chain. And hopefully we'll learn a bit about Smart Sam. I think that was in the brief. So that's not a clever chap, or I expect he's a clever person. Perhaps he is. And it's an advanced AI tool that we're going to learn more about, I think, as we progress. We've got a Q&A box, so if I could ask people, please put your questions in the Q&A. Hopefully we'll have some time at the end to go through those, but there's also a chat box as well. But if you could put your questions in Q&A, it's just I can't guarantee I can monitor both. And then sorry to be stuck with me. I thought to set the scene and help our speakers just gauge where you are as our audience. I was hoping to run some quick polls. So hopefully the technology will work. So first question is around your preparedness. So let me launch that poll. It should pop up in the chat, I think. There we go. So your names won't be recorded, so you can do this anonymously. We won't know what you're saying, but how prepared is your organization to trial an AI tool? So in terms of staff, data, budget, prepared, very prepared, somewhat prepared, neither prepared, somewhat unprepared, very unprepared. So what are your views on that? So hopefully that will pop up in the chat function, and that's great. Okay, so we've got some answers coming in. Thank you. So interesting. So somewhat prepared seems to be ahead of the list, which is encouraging, actually, I think. But yeah, see what you make of that. And I was going to go into a bit more detail, if I can. So let me close that poll. And then in terms of the potential benefits of AI, which ones interest you the most? Is it faster design, less material waste, fewer errors, rework, better forecasting, something else? Please don't say something else, because I couldn't add the box to say what. So if you could please take a look at that poll, and we might come back to look at some of the answers you give in these polls again at the end. So let's see if you've changed your mind, as it were, changed your opinion. So thank you for bearing with me on this. So yeah, that's interesting. So faster design, fewer errors seems to be where we're at on that one. That's super. Thank you. Okay, I hope this is useful, Azar and Abiodun. And then I was going to indulge you with a final one, if I can. I promise you, this is my last one. Let me just close that poll down to avoid any confusion. So, which workflow stage do you find most time consuming in your job at the moment? And you think, yeah, that might be useful to get AI. Oh, sorry, someone at the door. AI to improve that. So, is it design, fabrication, installation, or something else? Which workflow stage do you find the most time consuming and would consider applying AI to improve? So let's see how we're going on that one. So wow, yeah, overwhelmingly on the design side. That's very interesting. Okay, so as our Abiodun, I hope that's been useful to just soak up a few minutes.
Yeah, yeah. Thanks,
Looking
Justin.
at that, and I apologize for for soaking up your time on that. But and thank you for indulging me as the audience. But let me now introduce our speakers at last. So Azar Nalakath is a digitalization and technology associate at VLab and has a civil engineering background, which is good. Specialized in VR and AI and 3D scanning, so a lot of experience around laser scanning, BIM, digital twins, that type of thing. So very much an interest in sort of streamlining workflows and resource management. And Azar will speak to us first, and then Azar will introduce his colleague Abiodun Ayodeji from Brunel Innovation Centre, part of Brunel University London, although you're based in Cambridge, I think, aren't you, Abiodun? And he leads a research team that leverages cutting-edge AI tools to solve business challenges in a number of sectors, including construction, and worked on a number of innovative tools and AI-based solutions to optimize business processes. So that's quite enough from me, guys. So Azar, over to you, please. Thank you.
Thank you for the introduction, Justin. I just share my screen. Let me know that if that's visible. Sorry. Yep. Hello everyone. Thank you for being today. And thank you for the introduction to Justin. So my name is Azhar Nalagat. I'm a digitalization and technology associate at VLab. So what that means is I work as a virtual training VR training developer. Also, basically means I build AI-driven VR training solution, the kind of training that make training safer, more engaging, and more effective. As mentioned earlier, I also work on reality capture, site scanning, quality testing, and digital twins. Fancy terms, but really it's all about bringing real-world environments into the digital space. So the idea is to show that we can train people better. And my background is in civil engineering, so I have always been interested in how technology can improve construction, manufacturing, and installation processes. And that's exactly why we are here today to talk about one of our projects called Safe Extend. So it's an AI-powered virtual reality training platform, and I'll be showing you how it can transform the training and the industry. So um, before we talk much about how Safe Extend work or what it is, let's spend some time to actually see what's the issues, why we need a better training in the industry. So one of the biggest challenges that we are facing across fabrication or construction or any industry is the skill shortage. The demand for workers, skilled workers, uh, is increasing, but the supply is not just keeping up. A lot of experienced workers are retiring, and we are struggling to replace them fast enough. Now, the traditional way of learning on the job, it doesn't just scale anymore. So we can't afford to wait years to hire new people, gain the expertise they need. And especially our industry with that requires very specialized skill set like handling large glass panels, installing facade, operating machineries. what else, like applying the sealants. So if the workers don't get proper training, it's not just about inefficiency. It can lead to major safety risks, and that means costly mistakes. So, and apart from that, we have the way how we train people today. So it's either classroom based, where workers sit through long presentation, or it's on-the-job training where they shadow experienced workers. So neither of these are particularly efficient. Why? Because in the first case, the traditional training lacks like hands-on experience. You can show someone how to handle things, but unless they actually do it, they're not going to build that muscle memory. So throughout the presentation, the keyword will be muscle memory. So just keep a note. So, and second way, the second case, training is often inconsistent in the second case. Some people get great mentors, but while others, they might not get it. So it's hard to standardize the training across multiple location and job sites. Now, let's get real for the fact that this industry is dangerous if people don't know what they're doing. So you've got workers handling fragile, heavy materials, sometimes at extreme heights or in high pressure environments, but we just can't afford to have mistakes. And according to industry reports, a significant percentage of workplace injuries that comes from improper handling of materials or falling from heights during installations and so on. So when workers are undertrained, they are more likely to take like unsafe shortcuts that might lead to accidents, um, damage to expensive materials, or sometimes even legal liabilities for companies. So these are some challenges in the industry. So the last one is like, especially in a diverse workspace, language barrier. Many workers in the industry come from different backgrounds, different and traditional training materials might not always be effective for them. And then there is the issue of memory retention. So research shows that nearly 50% of people, so of what they learn within a day, if they don't actively apply, by the end of the week, by end of the day, they will forget it. And by the end of the week, that number may be up to 90%. So just a few things, like we have skill shortage, we have training methods, safety risk, and retention challenge. We have all these issues. These are big problems. But we have a technology-driven solution, and that's what we have. That's what Safe Extend is built for. So before introducing, we talked about why the traditional training is not enough. Now, let's talk about why Safe Extend works. To explain this, I want to introduce you to something called the Edgar Dale's Cone of Experience, which basically explains how people learn best. So on the top of the cone, we have things like reading and listening to lectures. These are the least effective way to learn, because honestly, most of us will forget almost everything we just read or hear after a few days, just like in this session. Maybe you might not remember it. So when we go one step down to things like seeing visuals or demonstrations, that's slightly better. Maybe watching an expert do something, but still it's passive. You're not actually doing the task yourself. But at the very bottom of the cone, this is where the real learning happens. When people physically engage in an activity like simulating a task or solving a real world problem, they retain up to 75% of the information. And this is why Safe Extend is different. Like it takes the training from passive zone where people just sit through lessons, to the active experience zone where workers actually practice their job in an interactive, site-specific environment. Now, here's the key difference. Safe Extend is not a generic VR training. It's built to be site-specific. What that means is, instead of just throwing workers into some random training environment, we actually scan and recreate the real world job sites. We take your factories, your workshops, your installation sites, anything you have, and we build a 1:1 digital replica inside the VR system. So when the workers train, it's not just some abstract scenario, it's their actual job site, their actual workflow. So this eliminates the disconnect between the training and reality. So workers don't just learn in a simulation, they learn in their environment with the exact processes and their exact safety procedures and with their actual equipments. Let me give you an example of how this works. So let's say maybe you have a new worker joining an installation team. They have never handled large glass panels before, or maybe you're training someone to do that. Now, if they're training them in the traditional way, the first time that you have to give them you have to show them maybe watching a video, maybe manual, they might understand what the process, but when they actually get on site, everything changes. The weight distribution of a heavy glass, the way it reacts to movements, the way wind or temperature might affect the handling. So these things can't be learned from a book, and this can be learned from a hands-on experience. But there's a great risk associated with safety and costs. So what if someone drops a glass? That's the issue. So, but with Safe Extend, we simulate the entire experience in VR. The worker can actually practice lifting, tilting, securing large glass panels, everything in a 1:1 virtual version of their job site. And because it's risk-free, they can make mistakes. You can make mistakes as many times as you want in the VR and without damaging real materials or putting themselves in danger. So what we are doing here is not replacing the hands-on training, but supplementing them. We are bridging the gap between the training and reality so that by the time they actually handle the real glass, they have already built the muscle memory and instinctively know what to do. Like it's an instinct, so they just do things. Another example will be in safety procedures like maybe fire evacuation training. So think about how fire evacuation training is typically done in most workplaces. Like many workers are given a handout with exit routes, or they sit through a safety briefing. Maybe they have a fire drill once in a week or once in a month or once in a quarter. And but then even it's controlled, predictable, and the problem is that they don't really simulate a real emergency situation. But with us, we do things very differently. So instead of telling workers what to do, we actually place them inside a simulated emergency scenario. Imagine you are in a VR environment and suddenly there's a fire alarm. Smoke starts to fill the room, the exits are harder to see, maybe hallway is blocked. What do you do? So this is where we have teach instinctive reaction training. So workers physically navigate the evacuation route in real time, in and this is done in a digital replica of their actual workplace, not just a generic office or building. So they experience what it's like to find alternative exit, how to handle low visibility, and even how to assist the co-workers safely. And the goal, that's muscle memory. So in a real emergency, they don't panic. Instead, they react because they have already been through this in VR. So this doesn't apply to like fire drills. So we can simulate anything you want in case of safety procedures like chemical spills or for any thing that you need like workplace hazards. So the idea is to prepare workers for exact safety challenges that they will face on the job. So um, we have covered why Safe Extend works. Now let's talk about how it actually does what it does. So the way we achieve this, the way we do this is through three core steps. The first one is site-specific scanning. And then we have AI-assisted virtual model generation or creation. And then we have tailored training modules. So the first thing, the site-specific 3D scanning, which is a crucial part of making the training much realistic and relevant. So what we do is, how do we capture this? How do we create a digital replica of your site? So we use high precision scanning technologies, like we have LiDAR, we have 360-degree cameras, we use drone photogrammetry, and even handheld scanning devices. And we do this to capture every detail of your work environment. Now that part is done. We got the data. Next step is making use of AI to create a digital replica of the site, which Abhiran will be explaining in detail in the next session. Now, once we have the site digitized and the AI-built environment, we move to the most important part, tailored training modules. Every company, every role, every worker has different training needs, right? So someone working in fabrication might need a different training approach than someone working in installation. So that's why we don't have a one-size-fits-all training solution. It's adaptive. So training programs are customized based on specific job roles, skill levels, and company standards. And the best part about this is, since this is a virtual environment, workers can repeat training as many times as they need without the risk, without material waste, without disrupting ongoing projects. So let's just talk about some some real world use cases that we have. So one of the most immediate thing that comes to my we had was refresher training. Now, here's the issue. Skills fade over time. So if workers are not actively practicing and reinforcing their knowledge, they start forgetting key details. For example, if a fabricator working in a glass cutting machine might only need to adjust a certain setting, or I'm not really sure about that, but they might not just need to adjust certain setting or safety measures once in a while. But if they go months without doing it, they might forget the exact process, and that could lead to costly mistakes or injuries. So we solve this by offering quick, short, immersive refresher training modules, and that allows workers to revisit and practice the key skills anytime they need to, and they don't have to wait for a formal in-person training or retraining sessions. Now, another major area that we focus on is equipment specific training. Another biggest challenge in not only in glazing but in all industry is that not all the equipments are same. So workers often move between different brands, models, generation of machines, or an even small variation in control. Anything can might cause confusion and can cause confusion. Yeah. So let's say a worker is used to operating one particular brand of glass lifting equipment. But then they move to a new project. They use completely different model with different weight distribution and things like that. So even though they're experienced, the small difference might lead to hesitation, and that can cause inefficiencies. Or imagine you are training new people, workers. You might not be able to stock upon all the type of equipment from all the manufacturers. That's expensive. So we can eliminate this problem where workers can train on specific machinery with a realistic scan, and they can learn exactly how to operate, adjust, and troubleshoot different settings before even they really touch the real thing. Now, another major challenge in the industry is language barriers. So, as I mentioned before, many teams are multinational, especially in the UK or Europe. The teams are multinational, multilingual. So, and while most of the workers are highly skilled, some might struggle to fully understand technical manuals, safety briefings, or complex training materials if they are not available in their native language. This leads to miscommunication, safety violations, and this can lead to mistakes. So that's not because they are not qualified or because they are unqualified, but because the training was not accessible enough. So with Safe Extend, the training is fully customizable for different languages, not with just subtitles, but with AI-driven voiceovers and interactive translation. Now, the last thing we have is the constantly evolving regulations. So for companies, this means one thing: keeping workers updated is now a never-ending task. So if a new safety protocol is introduced, how do you ensure every worker is trained immediately and correctly? So this is something what we can do. We can have instant updates to training modules. So the moment the new training regulation is introduced, we can update the training content, push it across the teams, and ensure that everyone is compliant without delay. So no need to reschedule in-person training, no wait for classroom sessions. Workers can have safe extend and complete the updated compliance immediately. So just to summarize, it's not about training once and forgetting. It's about ensuring that workers can constantly refresh, refine, and reinforce their skills, no matter what language they speak or how the industry evolves. So now let's take a look at how SafeX can transform a real training site into a fully immersive digital environment. So on the left here, what you see is an actual training ground. This can be anything. This can be a workshop, a construction site, or installation facility, anything that you want. On the right, what you see is the exact same space, but this is not the finished model. This is just a basic 3D mesh that which acts as a mesh for the fully complete training module. This is another site might be much more resonating with you guys with this construction site. So what I'm going to show you next is something our partner Tricor has created. So this is a perfect example of like how Safe Extend works in a real world construction environment. So this is a real construction site. We've scanned and digitally replicated it at a 1:1 scale. This is not just a rough model, so it's an exact high fidelity replica of the site. Every hazard, every elevation, every obstacle, everything is accurately placed. So the idea is workers can train in a fully immersive version of their job site before ever stepping foot in it. So when the workers put on the VR headsets, this is exactly what they see, the full construction site recreated in the digital form. And it's not just looking around, it's fully interactive. So workers can move through the site and navigate safety hazards, learn critical procedures without any real world. So whatever training you need, if you have a site, we can make it possible. Anything's possible here. We have in this side, we have scaffolding and fall protection training. We are also providing awareness about falling objects and site hazards. We give instructions on how to navigate confined spaces, emergency procedures as well. So everything we have seen today, from reality capture to AI-powered VR training, it's just one example of what's possible with Safe Extend and our site-specific VR training. So now imagine this same technology used for your industry, glazing, installation, anything you want. So the idea is to allowing your workers to master their skills before they even handle the real materials or tools, or be familiarizing with the site even before they're on the site. So if you're wondering how a company can integrate this type of training, we can talk to you about this, how to bring this into a workforce. You can reach out to us. We can have a talk about this, and we can discuss how Safe Extend can be tailored to you, like your specific needs. Just to recap, this is not just a new tool. This is what we believe, or I believe, that it's the next step in workforce training. Like every major technological advancement before this, this isn't here to replace the traditional training, but the idea is to supplement and to enhance how workers learn. So we now have the ability to train workers in real world environment, but without the real world risks. And we believe that that is the future of training, like faster, much safer, and more effective than ever before. So Thank you for the time. I'll now hand over to Abhi, who will give you more insights into how the AI aspects of the project works. So, Abhi, thank you.
Thanks, Azar. Good afternoon again, everyone. That was a very interesting presentation. Thanks. Let me share my screen. You see my screen, please. Azar?
Yes, it's still not in the presentation mode.
Yep, I'll do that. Thank you. All right. Good afternoon again. My name is Abiodun Ayodeji. I'm the data analytics team leader with Brunei Innovation Center. At Brunei Innovation Center, what we basically do is to look at industrial processes and the opportunities to apply our digital tools, be it AI, be it non-destructive testing, power ultrasonics, power electronics, and other digital innovation tools to solve industrial challenges or bottlenecks. All right. So how we do that is to come up with a proposal jointly with the industrial partner and submit this proposal to a few calls like Innovate UK and Horizon EU. And if it's funded, we sit together and then we do the technical stuff, right? So if you have a company or organization that is interested in R&D, please get across to us. That's my email right there, and you can see other contact information at the end of this presentation. Right. So Azar has already laid the foundation for this talk. So I really don't know. I don't want to dwell on the story that I wanted to narrate here to actually give you the idea behind this project. But I think Azar has done a very fantastic job in creating that background. So basically, we want the worker to get trained before they encounter the real world, because sometimes the real world is very chaotic, and can be intimidating when you are not skilled enough to work in the real world. A little bit of my background. My background is in nuclear engineering. And in the nuclear industry, we are always looking at how to get things right the first time, right? You don't want to go there and mess up stuff because it's very, very expensive to correct. Right? Mistakes in the nuclear industry is very expensive to correct. It can delay your project for years. It can cost you millions of pounds, right? So it's very important for you to get there and get through with what you are doing efficiently, right? And that's why I think this tool that we are developing, this project, is very important, both for the construction industry and other industry out there, honestly. So yeah, so this is all you are seeing on the screen is AI generated. Alex is not real, right? Alex is a hypothetical worker that goes to the job site the first time and gets very overwhelmed based on what it says on the site. And we are thinking in this project, how can we make Alex less nervous when he goes to the site, right? And one way is what Azar has already described. If Alex gets trained properly, it's very likely that he goes on site and does what he wants to do and get it right the first time. And one way is to actually develop virtual reality environments that represent the real world sites, and then Alex can play in this environment, put on the headset and play in this environment, do some task. Is very interactive, right? So this tool is very useful. You have already seen what Azar showed, but how do we come up with this tool, right? How do we make it very interactive, very realistic? How do we develop the environment so that what you see is exactly what you get when you go to the site, right? And that's where the AI aspect comes in, right? The question we are trying to answer here with AI is how do we optimize the VR content creation process or VR development process, right? And then we spoke with our partners, Tricor, and they came up with three different aspects that they think AI can be useful, right? The first is segmentation, right? They want to, for instance, you have a LiDAR scan. You go on site, you scan the sites, and you have this scan. Sometimes the scan is not perfect. Sometimes the scan has holes, right? It has noise, very noisy, it's very disorganized sometimes. So how can you make AI, how can you use AI to actually bring that scan to be useful in VR environment? And one way is to actually use AI to segment objects that you can now pick and drop in your VR environment, right? And that object can be a Zydos object or not, depending on your use case. Another AI application in this project is object counting. For instance, if you are an installer, you want to remodel or repair a hotel, and you have done this kind of the hotel, you have the letters kind of the hotel, and you want to count how many windows are in this hotel for you to know what you will manufacture and what you are going to install. For instance, you can just prompt. Is it possible to prompt the letter scan, and then get the number of windows in the hotel, the number of doors in the hotel, and the likes, and it depends on the material you are looking for, right? And again, when you are in a virtual reality environment, you want it to be as immersive as possible because attrition is a big deal. People drop out of even online courses if they don't get, if they don't get immersive experience. So one way we also use AI here is to actually develop realistic voice. Yeah, there are text-to-speech algorithms that we used in this project to convert text that you will hear in the VR environment to speech, and to make sure that that speech is as human-like as possible, right? And also there's a possibility to clone voices so that the user or the trainee can select the voice they want, and you can listen to the voice that you want in the VR environment. We think it's very, very important to retain people, retain attention while getting trained in the environment. So let me quickly share what we have done, the tools we have developed in the next few slides. That's what I'm sharing, the tools we have developed in this project and how that tool is transforming the VR content curation. In this photo you are seeing down is one of the scans that we have from our partner. Yeah, that's the real scan of a construction site. Because of confidentiality issue, we will not be able to show the risk scan the way it is. Apologies for that, but I guess this picture will give you an idea of what we work with here. So what we are trying to do is to segment that scan. What that means is that we want to pick and select objects from that scan and then turn that object into mesh, and then put that mesh in the virtual reality environment such that for a hypothetical worker, Alex, when it goes to site, it sees the exact object that is going to see on site in the virtual reality environment. So it's much more realistic that way. So there are a lot of models that are being used for 3D object extraction or 3D object segmentation, but they are still developing, right? They are not advanced yet. They are not in commercial use, and it's just at research stage. But for 2D object segmentation, is very advanced, right? You are also using some of those on your phone. That's one of the algorithms that you use probably to unlock your phone when you put your phone on your face and it unlocks automatically. That's 2D object recognition algorithm, but it's working on 2D for facial recognition and the rest, but it doesn't work well for 3D. So the question we are trying to answer is how do we build on this to make it work well for 3D data, for LiDAR scan and the rest. So that's what we use, one of the use cases for AI here. So for instance, if you look at a typical scan, this image is from a scan, it's a 3D point cloud. You can see that it's an image of a building under construction, right? It's clear to you, but the computer doesn't see it that way. The computer sees, thousands and millions of points floating in the space, right? So what we are trying to do is basically to make the computer see what you see as human being, right? That's basically what this aspect of the task is all about. So what we did was, instead of reinventing the way, because there are 2D models that work well, we just want to make them work for 3D data as well. So what we did was to build on 2D models like segmented entity model that's called SAM, right? Justin mentioned Smart SAM. We have changed the name because we have improved on Smart SAM. Smart SAM is now called Laser because we have included some other modules that make it much more smarter, right? So what we did was to develop a tool called Language Guided Zero Shot 3D Segmentation with multi-angle projection for point cloud analysis. And the acronym we give that tool is called LASER, right? And what LASER does is it takes your point cloud from you, right? And it cleans the point cloud, remove outlier, remove noise, it downsamples it. And then we install a virtual camera, probably a code software and virtual camera that we use to take images of the point cloud from different angles. You record that Sam uses image, so Sam has to take image input, just take point cloud input, right? So we use those images as sample into Sam, and Sam does the segmentation. But where the edict is now is to transfer the segmentation done by Sam to point cloud because Sam outputs 2D segmented images, right? So how do we, we project that into the 3D environment? So we have to come up with an algorithm that does that for us. So it takes the output from Sam and then projects into 3D segmented and then convert that to mesh. And the mesh is what is taken by our partner, Tricore, into Blender, and then they take each object apart, and then they can put it in that virtual reality environment and build the environment. So it shortens the time it takes for them to actually come up with the virtual reality environment that is being used to train construction workers, right? So another application of laser is object counting. For instance, if you have the point cloud, you want to know, like I mentioned, the number of windows in the scan, you can just prompt the algorithm, and the algorithm will extract the windows wherever they are and give them to you. And also, we are extending the capability such that you don't even need to prompt. You can speak to your point cloud, right? You can ask your point cloud how many windows are in the scan, and then you will get the windows extracted to you for you, and then you can hear voice, analyzing the window, the location of the window in the scan, how many windows are there, and the rest. So I think it's very important when it comes to 3D object counting, object detection. So this is the result of laser for segmentation. As you can see on your left, you see the original scan. In the middle is the laser segmentation. And on the right is the manual annotation that we did with human annotators. It took the human annotator about 2 hours to come up with the annotation that you are looking at here, but some took less than 3 minutes, right? It's a very fast process. But you can see that some output is not always perfect. It misses some points, right? But also, this is just the default application. There are a lot of modules that can be tuned, or a lot of parameters that can be tuned in the algorithm to make it much more better. So this is one of the outputs. The other output is the object search, right? As I mentioned, you can write a prompt to window. Okay. Apologies. Let me see if I can use this. Yeah, you can write this prompt to window and then put in your scan, and the laser will search for windows, extract the windows, and give it to you. Also, we can prompt for doors or any other object that you find fascinating in your scan or you want to learn about. The algorithm will extract those objects and give it to you. Then you can grab the object and put it in Blender or in any of these other tools, Cloud Compare, Autodesk Recap, to do other processing. Also, we have expanded capability, as I mentioned, to include voice, right? So instead of typing window, for instance, this demo shows that you can ask questions. How many windows in the scan, for instance? This is the question, this is the input, and Lisa gives you the output, right? Windows, and then you can hear this voice describing how many windows are in the scan. Apologies, I will have to exit this mode so as to share or to play this voice note.
Not coming out, Abiodun. Sorry,
Can you hear?
we're not hearing that one. No, sorry.
No hearing? Oh,
No.
so sorry. Let me reshare. I think it's okay. I see. See why. Apologies.
Garage or extension.
What about now?
Hello there. I can see 6 distinct
Yeah,
window
thank you.
openings on the house in the scan, 2 on the second floor at the front. Hello there. I can see 6 distinct window openings on the house in the scan, 2 on the second floor at the front, just under the roof peak. 1 on the ground floor at the front, near the main entrance. 2 along the side wall, 1 on each floor. 1 in the attached garage or extension section. I am not counting the large rectangular openings that appear to be doors or a garage entrance, as they are not windows.
Yeah, so that gives you the feel of what you can get from this algorithm in terms of voice and in terms of output from the scan. So let's rush through the rest of the PPT.
Hello
because we are
there.
pressed for time. So you must be wondering, what if you don't have LiDAR scanners? Because LiDAR has a lot of issues when it comes to the quality of the scan. It may have a lot of holes, like I mentioned. Also, you need the expertise to actually go to a site and scan with LiDAR and cameras. And then sometimes you need to use drones to capture the point cloud. Sometimes LiDAR can be very heavy. You need a lot of computing resources to process it. All this may be going on in your mind. What if I don't have the capability in my organization? What if I only have a mobile phone, for instance? Maybe you have an Android phone or an iPhone. Can you do something with it? Yeah, I think we have something for you also, right? There's another technique that we are exploring right now called Gaussian splatting or neural radiance field technique, right? Basically, you do not need LiDAR for this. You only need your smartphone, and you can walk around in construction sites and get the object of interest or area of interest. And this object or area can be converted to 3D model that you can import into your VR environment and create a story around it. So we think this is a very, very important improvement or updates when it comes to 2D to 3D modeling in VR. So basically what Gaussian splatting is not a machine learning based approach. It's just an algorithm that treats points as splats. Right, and the equation right here is showing how the smoothness of the splat is being is determining the dimension of the splat and the size of the splat that's being determined by this function right here. But for neural radiance field is a machine learning based approach. You need a multi-layer perceptron to actually use that technique. So, but these two techniques are different, but they give similar results and they work on photos, right? Images or videos, right? You don't need expensive LiDAR scan and the rest. So let me show you some kind of output from Gaussian splatting on neural radiance field algorithm. This is a video taken by a partner by just walking around his car, right? And we are able to convert this video to the object you are seeing here. Apologies, I will have to exit again so that I can show you. This is a 3D object. This is the car, right? 3D object of the car that you can just drag and drop into your VR environment, right? So that is one of the capabilities that we are empowering our partners with when it comes to AI. Also, this is just a flat image. It's not even a video. It's just a single image. We drop it into the algorithm, and then you can get something like this in 3D. And this can be exported into your VR environment and can use it. Right. There are other items or objects that we have converted. This is another safety vest. So it's another output from the Gaussian splatting algorithm. This is a hammer. You can drop it and the avatar can actually use it in the VR environment. These are houses also converted from the algorithm. So this is safety goggles, just to show you what is possible with this algorithm, right? And then there are other things that we also converted. This is another tool that we converted for partner Tricon. I think this is from for Tricon, and this is a drill from just an image or 3D or video, just 5 seconds video of the object. You can get your 3D model and you can import it into the Unreal or Unity and you can build your virtual environment. So that's some applications of the AI in this work. All right, so let me see. I think I have a few slides to go. Apologies. So benefit, of course, is very good for automation. You can automate some of these processes. You don't need to do a lot of manual work. It shortens the time it takes for you to probably inspect if that is your use case. And also it gives you much more realistic output, right? And who is it for? It's for everybody that uses either point cloud, if you want to use laser-based approach, or virtual reality content creation, if you want to use the Gaussian splatting approach, BIM development, robotics, and also hopefully for glass manufacturer, glazers, and installers. And I see that most of you are interested in design. I really love to hear what you would like to use AI for when it comes to design, right? So we have a summary table of how it can be useful for you. But again, you wear the shoes, you know where it pinches, right? So we'd like to hear from you where you think this technology can be applicable, right? Thank you very much. We take questions now.
Thank you very much, Abiodun and Azar. Yeah, so everyone's on mute, so you can't hear the cab clap, but yeah, there's a cab clap going on, I'm sure. Thank you. That was really really interesting. I can't see any questions in the Q&A box. Feel free to put your hand up if you'd rather speak, and I can unmute you, I think, manually and do that. That was very interesting. And it's interesting, obviously, as an industry with, I think this is more of a comment on my side in terms of, obviously, post the Grenfell Tower tragedy, competence is a big issue in our sector in terms of training and how installers, etc., are trained. And I think it's interesting. Just the other day, we were having a discussion around, well, classroom training is all very well, but you need to get them out, sort of boots on the ground, as it were, to actually see how this works. And your presentation gave a tantalizing view of a sort of halfway house, really, that where you could use that as part of the training. So I guess it comes down to cost at the end of the day, doesn't it? For a lot of people. So I appreciate the work you've done in making it more accessible through using mobile phone, for example. Being able to reduce the cost of it, I think is really important. So I think we'll need to look at how we might work with yourselves and AI to sort of bridge that gap, if you like, between sitting in a classroom and actually engaging people with the reality, and then how do you do that without the cost and, as you say, the real life dangers that you have. So not just health and safety, but also more widely. Maybe if I could ask more of a question in terms of, obviously, when we did the polls, design sort of came up as a big sort of area where they thought this could potentially be really useful. I wondered if you could say a little bit about how you would see that helping in the design workflow.
All right. Is that regarding the AI application or the design of the pole itself in VR?
Good question. I suppose it's a bit of both, really. But yeah, let's take the initial design from you've got a piece of paper and you're starting out with the design process.
So there are two ways, Justin, to answer this question, because I don't really know how you design in your industry. But industry I'm familiar with, we use CAD tools, right? All these softwares.
AutoCAD, yes, absolutely.
Yeah,
Yes.
yeah, to design, all right. So if that is that's the approach, the area you are looking at it from, there are a lot of applications that are using AI to actually aid what you can come up with in CAD, right? Computer, when it comes to those softwares and the rest. And if you have a tool, you have your design, you want to optimize your design. There are also tools, AI tools that you can use to actually optimize the kind of design that you can do with the tools. But what I have seen work is using the tool in its original environment, right? For instance, maybe you are using some CAD tool, you want to use AI, it works best if you have your AI in your software as opposed to using, for instance, the algorithm I presented and then using the output in the CAD environment. Because sometimes that interface just doesn't scale. When you have the output from the algorithm and you want to use it in the CAD environment, it doesn't scale. So one use case is actually to use a software that is being integrated in the CAD and then use it to optimize your design and get the output and put it in the VR environment. But when it comes to the VR itself, I think Azar can speak more on how it works.
Yes, thank you, B. So when it comes to design and using VR to better manage that, one of the things that we could do is design validation in the virtual environment. So you have the actual site in there that we have scanned. You can validate your designs in there. Or talking from just pure perspective of using VR and AI, you could have create the design inside the VR, like the whole 3D session, you can see on the scale. And I believe all these could really make a better perspective from for the designer. It would really make an impact on them.
Yes. Okay. Thank you. And sorry, stupid question probably from my side. In terms of, could you use the scan? Let's say you're on a building site, you scan a building, you have holes for windows and doors. Could you use that data to input on your production line straight away without any input? So I wouldn't have to go up to the window with the tape measure. Would that be, is that one of the areas
Yes.
you see as potentially helping in terms of take the picture, off you go, put it into your production?
Yes,
Could it work like that?
definitely. Yeah, definitely. So the way we capture that, one of the ways we capture the data is we using LiDAR sensors, and they are really accurate to the level, millimeter level. So and even I know people using LiDAR technology to get off readings, measurements and things, and this will be a really good use case for the designers as well. They
Yes.
could really take off the design, take off the data from there, and you can even design within the framework of the scan. So yes, that's a real good possibility there.
So this is my hole, and I could put this in or this or that. Yeah, yeah.
Yes.
We do have a question from James, and I appreciate we're running out of time. Is all AI VR training recognized legally? That's a good question. So, for example, if an accident happens and the person has been trained using AI VR, how does it apply legally and insurance liabilities, etc.? Yeah, that's an interesting question. I don't know if you have any thoughts on that, either of you.
Yeah, it's a very interesting question indeed. There are safety regulations that guide the development and implementation of AI algorithms itself and the output thereof, of course. But in this use case, I'm not so sure as if there are regulations that actually guide how you use VR. I'm not so sure if that exists.
To be honest, I can't answer the legal implication of that, but I'll give you some point here. So we have been working on the similar projects using VR and AI, and many regulatory bodies like GW. So this is not for the glazing industry, but for offshore industry like GWO. What happens is that they are actually promoting use of VR in the training scenario. So since COVID hit, things have been going remote training has been they have been promoting that. So regulatory bodies are in favor of that, but as far as the legal implication, that's still some areas to explore and collaborate with.
Yeah, I guess.
Yeah.
Is there? Yeah, I guess is there a difference between classroom training or AI VR? So someone's asked, how would AI work for retrofit where buildings vary considerably and aren't uniform? Is it the same process? Is that James again? I'm not quite sure if. Do you mean you'd have to scan each thing separately? I think that's what.
Yeah.
I think
Yeah,
that's what
that question.
James mean.
Yeah, it is not very clear. But let me try to answer that if I get him correctly.
Thank you.
So it depends on what use case that you want to use it for. For retrofit, if you can scan or if you can take your phone and then probably get the image or video of the building you want to retrofit, yeah, it works. All it does is just take that scan or the image or video and convert to 3D model, which you can use actually to train or even to retrofit in the VR environment. Yeah. So if that is your question, yeah, it's very possible to use AI to actually, yeah, improve on retrofitting.
Yeah, it would need individual scans as you followed up, James. Yeah.
Yeah, of course. Yeah,
You can't. AI
yeah.
can't. AI can't. Yeah, it's not that clever. Yeah, to
Yeah, of course.
to look into the future. No, I'm sorry. We seem to have run out of time. I do apologize, but my saving grace is that we have invited Azar and Abiodun to speak at our technical conference. So we look forward to welcoming you back in real space on 15th of May at our technical conference. So everybody on the call, please look out for that. We can explore that in more detail. Indeed, Azar, I think, is taking on a tabletop, so we can actually have some VR headsets. And I know you were asking if we could do that now, and I wasn't sure. So maybe that's something we can save for the 15th of May. To get people looking silly from the outside, but in their own headset, if that makes sense. Yeah, all that remains, I guess, for me to say in the time is thank you very much, Azar and Abiodun. That's been a really interesting presentation. Some of the comments have been very positive. And just to say to those on the call, we have our next session on Tuesday, 11th of March. So we're going to look at noise, ventilation, and overheating with some acoustic consultants. So I'm sure that'll be very interesting to address some of those questions. But meantime, if there aren't any more burning questions, I will wish you all a very good day. Thank you for joining. Thanks again to our speakers, and yeah, look forward to seeing you all again soon. So thank you and goodbye.
Thank you for having us. Bye-bye.